Hi everyone. Before we get started, please can you just put your student numbers in the chat just so that we can use that for attendance. Okay, so today we're going to go through the beginnings of trig substitution. So it's similar to U substitution that we did in the past. However, now we are specifically substituting certain trig functions. Okay, so we're going to go through which trig functions to substitute for which problems. There's 3 cases you need to worry about, and then we will look at some examples. Okay, so case 1. Okay, so for case 1, we are looking for integrals that have the following term. So it's something like the square root of a constant minus x squared. Okay, so if something like this appears in your integral, then you're dealing with case 1. So for case 1, we need to make the substitution of x is equal to a sine theta. Okay, so that's the substitution we're going to make. Now, why do we do that? Let x be a sine theta. Well, consider the root that we have there. We have the square root of a squared minus x squared. Okay, now that's pretty complicated, but what happens if we make the substitution now? It's going to be the square root of a squared minus a squared sine squared theta. So I've just substituted x there. Now we can simplify this. This will be the square root of a squared 1 minus sine squared theta. Okay, and then 1 minus sine squared, that's going to be cos squared. So that's going to be the square root of a squared cos squared theta. And that's just going to be a cos theta. So you see, after making the substitution, this is a lot simpler than the square root of a constant minus x squared. So this is simpler to work with. Yeah, so whenever you have something like a squared minus x squared, you need to make this substitution to make the integral easier. Now, notice after making the substitution, the resulting integral will be a trig integral. You know, the ones that we covered last time. So it's important to go over that. So after the substitution, the integral will become a trig integral like we had before. Okay, so remember those trig integrals, like with the sine squared, cos cubed kind of thing, those are going to come up here as well. Okay, so it's important to go over trig integrals again if you need to. Okay, just for those students that have just joined, please remember to put your student number in the chat, just so that I can keep track of it for attendance purposes. Okay, so this is the first case, okay, a squared minus x squared. Let's take a look at the next case, case 2. Case 2. So this is when we have something like the square root of a squared plus x squared. Okay, so the minus became a plus now. So in this case, we're going to make the substitution x is equal to a tan theta. Okay. Okay, so why are we choosing this as our substitution? Well, let's check what happens when we substitute it in. We're going to have the square root of a squared plus x squared, and we're going to substitute x now. So it's going to be the square root of a squared plus a squared tan squared theta. Okay, so we can simplify this. We're going to have a squared 1 plus tan squared. And we know that our density, 1 plus tan squared, is going to be sec squared. So we have a squared sec squared theta. And then after we take the root, it's just going to be a sec theta. Again, it's simpler than before. Okay, so instead of dealing with the roots and the squares, we only have to deal with some trig functions. Okay, so that's case 2 when we have the plus in between. And then case 3 is the last one to deal with. That is x squared minus a squared. Okay, so just to go back to case 1, this was a squared minus x squared. And then we swap that around for case 3. So case 3, this is when we have something like x squared minus a squared. Okay, so we swap those around from case 1. So in this case, we're going to make the substitution x is equal to a sec theta. Okay, so why do we make this pick? Well, let's see what happens when we substitute. We're going to have the square root of x squared, so let's rewrite that, x squared minus a squared. We make the substitution, we're going to get a squared sec squared theta minus a squared. Here we can factor out the a squared, so then we have sec squared theta minus 1. Okay, now remember, tan squared plus 1 is sec squared. So sec squared minus 1 is tan squared. So this is going to be square root of a squared tan squared theta. Taking the roots, we get a tan theta. Okay, so this root with x squared minus a squared, we replace that with just a trig function. And again, if you go over your trig integrals, you'll see that these integrals will be a lot easier to solve than the ones involving roots of x squareds and so on. Okay, so this is, again, simpler to work with. Okay, so that's the reason why we make these specific substitutions. Okay, so let's just do a little summary of that so that we can refer to it later. Okay, so if your integral has the following, a squared minus x squared, then we say x is equal to a sine theta. And then, of course, dx will then be a cos theta d theta. Okay, if we have a squared plus x squared, then we say x is equal to a tan theta. And then the derivative of tan is sec squared. And lastly, if we have x squared minus a squared, so we swap it around from case 1, then we say x is equal to a sec theta. And then the derivative of sec theta is sec theta tan theta, d theta. Okay, so those are the 3 things you need to look out for. So the first column is what's going to appear in your question. The second column is the substitution you need to make. And then the third column is how you handle the differential. Okay, so we're going from x variables to theta variables. Okay, and then just a note. After the substitution, you will have to solve a trig integral. Okay, so if you need to go over your trig integrals, please do that. Okay, so that's just a summary of what we need to do. Okay, are there any questions so far? Okay, so it's just a list of substitutions you need to make, okay, depending on what you're given. Okay, so let's look at an example for each of them. So example number 1. Okay, we have the integral of the square root of 9 minus x squared all over x squared dx. Okay, we want to figure this out. Now, right away, we see that in the numerator, we have the square root of 9 minus x squared. Okay, so it's something like the root of a squared minus x squared, where a is 3. So we go back to our table here. We see we've got 9 minus x squared. So that looks like this case 1 that we're working with. Okay, where a is 3. Okay, so we're going to have to make the substitution x is equal to 3 sine theta, and then turn the integral into a trig integral. Okay, so just a note here, this over here is something like a squared minus x squared. So we need something like x is equal to a sine theta. Okay, don't worry about the denominator just yet. It's the top part that tells us what substitution to make. Okay, it's always whatever the root is, that will tell you what to do. Okay, everything else, that's extra that we need to work out later. Okay, so x is equal to 3 sine theta. So dx is going to be 3 cos theta d theta. Okay, so let's do the substitution now. So this is going to be the integral square root of 9 minus 9 sine squared theta over x squared is going to be 9 sine squared theta, and dx is going to be 3 cos theta d theta. Okay, so wherever there was an x, I substituted, and then the dx I substituted as well. Okay, so what does this all become now? So this is going to be the integral. The root will be 3 cos theta, okay, because of the 1 minus sine squared becoming cos. So we're going to have 3 cos theta over 9 sine squared theta. And then we still have this 3 cos theta on the side. Okay, so we just simplified the roots. Okay, so this is going to become, the 3 times the 3 will be a 9, but we're dividing by 9, so that goes away. Cos times a cos, that's cos squared. So we have cos squared theta over sine squared theta d theta. Okay, now sine squared over cos squared would be tan squared, but this is flipped around. We're taking the reciprocal. So cos squared over sine squared, that's going to be cotan squared or cot squared. Okay, now integrating cot squared is very similar to integrating tan squared. We need to use that identity with cosec squared instead of the one with sec squared. So just as a little side note here, if we were integrating tan squared, okay, we did this one before, we need to change the tan squared into sec squared. So this would be sec squared x minus 1. Okay, so similar idea over here, but instead of using sec squared, we need to use cosec squared because we've got cotan squared. So this is going to be the integral of cosec squared theta minus 1. Integral of cosec squared, that's minus cotan. Integral of 1, that's just theta plus c. Okay, so we've done the trig integral, but we're not done yet because remember, we did a substitution here. So we've changed from x variables to theta variables. We need to go back to x variables. Okay, so let's make a note here. Need to go back to x. Okay, so how do we do that? Well, we know the relationship between the two. We know that x is equal to 3 sine theta. So let's start off with that. So x is equal to 3 sine theta. With a little bit of manipulation, we see that sine theta is going to be x over 3. Okay, so how does that help us? Well, we know that sine theta is defined as a ratio, right? So the trig ratio. In other words, if we draw a little triangle here, and we put theta as our angle, then sine theta will be opposite over hypotenuse. So the opposite will be x, the hypotenuse will be 3, and what's the adjacent going to be? Okay, well, that's just Pythag to work out the adjacent, but that's going to be 9 minus x squared. Okay, you can check that using the Pythag formula. So now we've got the opposite, we've got the adjacent, and we've got the hypotenuse. So if we want to work out cotan theta, we've got the triangle. So we can work out any trig ratio using this triangle. So we can now work out any trig ratio from the triangle. In particular, we can work out the cotan of theta. Okay, so how do we do that? Well, tan theta is going to be opposite over adjacent. Cotan theta will then be adjacent over opposite, because remember, it's flipped around. Okay. So it's going to be minus root 9 minus x squared, so that's the adjacent, over the opposite, that's x. And then what's theta going to be? Well, if sine theta is x over 3, then theta is going to be inverse sine of x over 3. So inverse sine of x over 3. Okay, and just need a bit of space here, 4 plus c. Okay, so that's the final step that we need to do in this case. We need to change from the theta variable back to the x variable. And the way that we do that is by drawing our trig triangle over here. Okay, once we've got the triangle, we can figure out any of the trig ratios. In this case, we had to figure out cot theta. Okay, but once we've got the triangle, it's really easy to figure out the ratios. Okay, I've got a question here. How did we get x as 3 sine theta in the beginning? You totally lost. Okay, so let's just go back here. So I highlighted in yellow over here the root of 9 minus x squared. That tells us which trig substitution to use. Because if we go back to the table here, we are using this first row. Okay, where a is equal to 3. So if a is equal to 3, we get root 9 minus x squared. So a is 3. Okay, so this tells us what substitution to make. X is equal to a sine theta, but we said a was 3. So x is equal to 3 sine theta. We go back here. That's the substitution we make here. Once we make that substitution, everything then turns into a trig function. Okay, because x is a trig function, so everything else becomes some trig function as well. So we replace x with 3 sine theta. We do all the trig identities if we need to, and after simplifying everything, we end up with a trig integral. Okay, now we've done lots of trig integrals before, so we just evaluate the trig integral, and then for your final step, we need to go back to the x variable. Okay, so how do we go from trig functions back to x variables? We use the substitution. So if x is equal to 3 sine theta, then if we draw the triangle with the opposite and the hypotenuse, okay, because sine theta is opposite over hypotenuse, we can fill in the other side. And that means we've got all the sides needed to write any of the trig ratios. In particular, we have cot theta. So cot theta is adjacent over opposite. So we put in the adjacent, we divide it by the opposite, and that's cot theta. And then theta is just going to be inverse sine of x over 3. Okay, so I just inverted this formula over here. Okay, but everything is just from that table there. Okay, I've got another question here. Is it always going to be in a square root? Yes, so this is the table you need to learn. So you got the roots over here, you do your substitution, you change your differential, and you get your trig integral. Okay, now, just because it's a root clearly written here, doesn't mean it's always going to be like a square root, because remember, I could do something like this. Just make a little note here. Let's say we've got root 9 minus x squared, but then I cube that. Okay, so there's still the root. Okay, we still got the root here. It's exactly the same. But I could also write this as 9 minus x squared to the 3 over 2. Okay, so this 9 minus x squared to the 3 over 2, you see the square root is hidden there. So it's not clearly a square root, but it's to the power 1/2. So there's still the square root there. Okay, so you might not always see it as the square root sign. You might see it as something to the power 3 over 2, but there's always the square root. Okay, so there is always the square root. Okay, but sometimes it's a bit hidden in the exponent. So an exponent of 3 over 2, there's still the square root there, even if you can't see it right away. Okay, no other questions there. Okay, are there any other questions before we go on to the next example? Okay, let's have a look at the next one. Okay, so this is number 2. So now we have the integral of 1 over x squared square root of x squared plus 4. Again, we've got the square root here, so that tells us we need to do our trig substitution. Which one do we need to make? We go back to the table. Okay, sorry. Okay, it is x squared plus 4. So that's going to be case 2 over here. Okay, where a is 2, because 2 squared is going to be 4. So the substitution we need to make is x is equal to 2 tan theta. Okay, so we've got our substitution. X is equal to 2 tan theta. Okay, we just look at the table, we see what we need to do. Okay, so we've got x. What's dx going to be? The derivative of tan is sec squared. So we're going to get 2 sec squared theta d theta. And that's everything we need for the substitution. So let's take all of this and substitute now. So we're going to have the integral of 1 over x squared is going to be 4 tan squared theta. The root of x squared plus 4 is going to be the root of 4 tan squared theta plus 4. And dx is going to be 2 sec squared theta d theta. I've just substituted everything there. Okay, now we need to try and simplify this. So this is going to be the integral. We can put the 2 sec squared theta at the top. At the bottom, we're going to get 4 tan squared theta. And then for the root, we can take out the 4, and we're going to get tan squared theta plus 1 d theta. Now, tan squared theta plus 1, that's our trig identity. It's going to give us sec squared. So this is going to be the integral of 2 sec squared theta over 4 tan squared theta. And then after we take the root, it's going to be 2 sec theta. Okay, so I just took the square root over there. Okay, now we can clean this up a bit. At the bottom, we've got 4 times 2, which is 8. At the top, we've got 2. Okay, so 2 over 8, we're going to end up with 1/4. We can take that out. Integral of sec squared theta divided by sec theta, we're going to have a sec theta at the top. At the bottom, we still have tan squared theta. Okay, so now we've got ourselves the trig integral. So trig integral to then solve. Okay, so now we just think back to when we did trig integrals and we think, what do I need to do to solve this one over here? Okay, so it involves sec and tan squared. Okay, so let's try and simplify this. Okay, so 1 over tan squared, we can write that as cos squared theta over sine squared theta. And sec theta is 1 over cos theta. So that's going to be 1 over cos theta here. Now, cos squared at the top, cos at the bottom, they're going to cancel. So we have 1/4 the integral, cos at the top, sine squared at the bottom, d theta. Okay, which is good, because if we do a u substitution with u equals sine theta, then du will be cos theta d theta, which is at the top. So on the side here, we just do a little u substitution. U is equal to sine theta. Du will be cos theta d theta. Okay, so now I'll just keep this in green because we're doing the u substitution. We're going to have 1/4 the integral of 1 over u squared du. Okay, so that's going to be minus 1/4 times 1 over u plus c. Okay, but we don't want u. We want to go back to our trig function here. So u equals sine theta. We can go back to that. So we're going to have minus 1/4 times 1 over sine theta plus c. Okay, now we're almost there. We've got sine theta, but what we really want is to go back to the x variable. Okay, so how do we do that? Well, we start off with the substitution, x is equal to 2 tan theta. And we try to work out the other trig integral, the other trig ratios from that. So if x is equal to 2 tan theta, then tan theta is equal to x over 2. Now we draw our triangle. We put theta over there. Tan theta means opposite over adjacent. So the opposite is x. The adjacent is 2. So that means the hypotenuse is going to be x squared plus 4. Okay, so we've got all 3 sides to the triangle. We can find any trig ratio that we need. In particular, we want sine theta. Okay, so sine theta is going to be opposite over adjacent. opposite over hypotenuse, sorry. So it's going to be x over square root x squared plus 4. That's just from the triangle. Okay, so we substitute that in. We know what the trig ratio is. We substitute it in, and we get our final answer. So we get minus 1 over 4 times 1 over sine theta. So we flip that around. We get square root of x squared plus 4 over x plus c. Yeah, and that's our final answer. Okay, so you see that in this middle step of solving the trig integral, we had to use a u substitution. So please keep in mind that you might be using all of your integration techniques. Okay, you could be using a u substitution. There might be an integration by parts somewhere here, or definitely a trig integral. But please keep in mind, you're going to be using all of your integration techniques. Okay, so it's not, super straightforward, like you have to do one thing. There might be a couple things you have to do along the way. Okay, someone's asking here, how did you get negative from a quarter? That is this integral over here. The integral of 1 over u squared is minus 1 over u. Okay, so from here, from that step to the next step, we picked up a minus sign from integration. So pick up the minus from the integral. Okay, so then the positive 1/4 became negative 1/4 there. Okay, another question here. How you got the negative sign? Oh, okay, same question there. Yeah, so that's just from the integral. So integral 1 over u squared, that gave us minus 1 over u plus c. So then I just put the minus out in front. Okay, any other questions on this? Okay, sure. Okay, you got it. Cool. Any questions at all? Okay, let's put a little homework question here for the last one. So just find here, the last case we have to worry about is x squared minus a squared. So let's put that as a homework question. Okay, so we're going to have the integral, let's say 3x over the square root of x squared minus 1. Okay, so if we just go back to the table quickly, we see that here a is equal to 1. Okay, we've got the root of x squared minus a squared, but in this problem here, we've just got a 1 over there. Okay, so a is equal to 1. Okay, so it may not be a perfect square, right? It's just something that can be written as a square. So in this case, the 1, we could have written that as 1 squared. Okay, but it's the same thing. Okay, so I'll leave this for homework. Okay, so that is the last case where you make the substitution of sec theta. Okay, you can give it a go. And then I will post the solution later today on the WhatsApp group. Okay, so if you want to post your solution to have checked, please post it on the WhatsApp group. Or if you just want to wait for the solution at the end of the day, that's fine as well. Okay, but this is the last example for that last case. So tomorrow we will go through some more examples. Okay, some mixed examples, so it's not too clear which method to use. Okay, but we'll go through all of that. Wednesday is a public holiday, so we won't have a lecture. However, I will upload a prerequisite video. So it's just going through all the things you need before we do partial fractions. Okay, so it's all of the stuff you need to know before we get to that section. Then Thursday, you are going to write your quiz during the lecture, and Friday, we will go through partial fractions. Okay. I will see you. I'll see you tomorrow. Okay, we will go through the rest of the trig integral stuff. Okay, so if you do have any more questions, please let me know on the WhatsApp group. I can answer you there, or you can send me an email. I can answer you there as well. And remember, we do have the 2 tutors, though they're all also available on the WhatsApp group. Okay, so you can ask your questions to them as well. Okay, bye everyone. I'll see you tomorrow.